So today begins a lesson in polynomials. What a fun word, right? Polynomials. So by the end of this lesson, you'll be able to define what a polynomial is, and we'll be able to add and subtract polynomials, which is actually something you have done. You've just never done it, with the word polynomial involved. So a little bit of vocab here that's going to be important. A polynomial is any expression that is the sum or numbers or variables or terms. So again, if I'm looking at a polynomial, so I'm asked about a polynomial. What is it? Well, a polynomial could be a simple letter, like x, could be b, c, m on its own. A polynomial could be a combination of a letter and a number, also something that is considered a polynomial. And it could be a lot of things, like 3ab plus 4c minus 18. So a polynomial is like everything. It's like the broad category of things, of terms. And then we could have different types of polynomials. So a monomial, and emphasis on the prefix mono, a number, a variable, or a product of numbers and more variables. So a single y, a 2y, or a 4y squared, each one of those is a monomial. Now, I know that they have maybe sometimes more than one piece. They can have a number and a variable, but it's just considered one term when it's glued together with multiplication. So monomial, like Monopoly, right? When you play a game of Monopoly, only one person wins. At some point, Amazon is going to take over the world and there'll be a monopoly. I mean, they kind of already are, but they're getting pretty close to just everybody using Amazon for everything. And that is something that's a little scary. But anyways, mono meaning one. And then we've got a bicycle, and the prefix is important here because this is the sum of two unlike terms. Again, unlike meaning non-like, meaning not the same. So a binomial is when we add x and y, two different letters, or we add the same letter but a different exponent. Those are also non-like, or the combination of like 3x and 4. Again, two terms being added together. We can use subtraction, but that's really like adding a negative. So don't be confused if you do see subtraction at some point, but two non-like terms for a binomial, just like your bicycle with two wheels. And then the third one is a trinomial. Emphasis on the tri, the prefix, the sum of three unlike terms, and those terms could be three different letters, x minus y plus c. There's the subtraction. It's adding a negative, so it's got to be adding or subtracting that separates those three terms, or the same letter with a different exponent, again, making them unlike. And just remember, like your favorite dinosaur, at least my favorite dinosaur, the Triceratops, has three horns, prefix meaning tri. So next page, hopefully you're seeing it nice and clear with my new clear touch and my note presentation. So standard form is often really important for polynomials, and standard form is simply writing an equivalent expression, so we're not going to change anything, where the largest exponent goes first and then descending, so getting smaller by exponent. So pay no attention to the number in front, it's all about the exponent. So right here, 5x to the third, that is considered the largest term, so that's going to go first. Always include the sign in front. Then 3x squared. Now there is no sign in front, but we assume positivity, so 3x squared. And then the last one, minus 8x. Again, the biggest number, even though it's negative, I guess, not the biggest number, but negative 8 looks like the biggest number, but it's not really the smallest exponent, and so that's why it goes last. Now, what type of polynomial is this? It has the same letter, but three different exponents, 3, 2, 1. This is a trinomial, right? Okay, just kind of getting you used to that. Next up, we have 5 plus x to the fourth, and we want to write this in standard form, descending order. Be ready for either one of those. Largest exponent first. I know that this is just a 1, but x to the fourth goes first, and then the 5 would go next. Okay, so we switch the order. We're using commutative property. Remember that one from the beginning of the year? And this is your classic binomial because it has two terms, all right, two non-like things. And then we have a trinomial, 1, 2, 3 pieces in a wrong order. So I need to find the biggest exponent. I'm going to be first term as the largest exponent. So that's the negative 5x squared. Negative 5x squared goes first. Then minus 2x, because that has an exponent of 1, and then positive 3, because that doesn't have a variable, which means it doesn't have an exponent at all, okay? Now, curious to see what type of polynomial people think this is. 3 non-like terms that are being separated by addition or subtraction, okay? So there we go with the first exercise, and now let's take a look at number 2. So number 2 is just to get you a better understanding of polynomials, why we can add certain terms, and why we don't always add everything together. So think about a number like 523 and 271. We want to write each of these as the sum of multiple powers of 10. So stick with me here, it'll make more sense in the end, but for right now, 523 is really 500 plus 20 plus 3. Agree? All right, 523. And 271 is really 270 plus 1. Now, I can add these a little bit differently. I can add these as 5 times 100. 200 would be 2 times 100. There's 2 hundreds. 20 would be 2 times a 10. 70 would be 7 tens. And then there would be simply 3 ones and 1 1. I'll let you get all that down. Plus 2 times 10 to the first plus 3. And then 2 times 10 to the second plus 7 times 10 to the first plus 1. All right? Now, the whole purpose of this is to kind of help us see what we add. And you already know what we add. We add the ones, right? We add 3 plus 1 for 4. Then we add the tens place, right? 1 10. So this would be 9. 2 plus 7 is 9. And we keep just 10. And we keep it to the first power. We don't change it. That's 90. 9 tens. And then over here, we have 5 plus 2 for 7 times 10 to the second, right? 7 100s, or 7 10 to the second. Where in the world are you going with this, Petrie? This doesn't make any sense to me. Well, I'm about to wrap it all up here. Let's let x be 10. Okay, so if we think of this as 10 for x, let's replace the tens with x's. All right, so 5x to the second. I'm replacing this with an x, plus 2x plus 3. That one doesn't get an x because I didn't have a 10. And then the other one was 2x to the second plus 7x plus 1. And so if we add these terms, we're going to be able to add the 5 and the 7. All right, sorry, the 5 and the 2, and that makes 7, just like we did here. Just like 500 plus 200 makes 700. This is just x to the second. Now, 2x and 7x, think of that as like 20 and 70. That's really 9x. I'm adding the tens place. 3 plus 1 is 4. So there you have it. So now when we see two trinomials and we're asked to find the sum, we're asked to add them and put them in standard form, I think we should be ready to go, okay? So what can go together? Well, only terms that have the same x, the same letter, and exponent. So that would be this one and this one. Now, adding these terms is not going to change any of these signs. So we're simply going to write 1 plus 2 for 3x squared. Sometimes we could use different shapes, and look at my cool little shape marker here. I'm going to go with the 3x and the 5x. Those are like terms, right? So those can get together, and that would be, oops, not 8. They have a -5 and a 3, so that would be -2x. And then I need to identify other like terms. I'm going to go with hearts. 2 and 4, they like each other. And who's enjoying my new Clear Touch tools here? We end up with 3x squared minus 2x plus 6. Think of this as 300 minus 20 plus 6, right? where each is in a different place value. Now, not the answer, because we don't know if x is 10, but that's what we're kind of getting to the point to. All right. Over here, find the sum of these polynomials. There's nothing in parentheses, so we're allowed to rearrange this however we see fit. But again, we got to find like terms, so I'm going to keep going with my fun shapes. There's an x to the second power. There's another x to the second power. So those get put together for 3x to the second power, because I only add the number in front. This part stays the same. And then I find other like terms. Let's go with the moons here. 9x with the negative 5x, okay? And so you add those together, but we really subtract because the signs are different, so it's positive 4x. And then the last thing, we find more like terms, 3x, negative 3, positive 4, and we end up with positive 1. Again, 3 different terms, making it a trinomial. And the reason why it's a trinomial, each one of those x up here. So on the back, subtracting these, well, be careful because we have to rewrite them as an addition problem first. So for instance, if I've got this negative here, that actually is affecting the entire trinomial. So we're subtracting 2x, and a negative, we're really adding the 4x, and a negative to the positive 7 is really subtracting 7. So if I've changed all those signs, now I can think of this as really adding these. But again, 6 plus negative 2 isn't adding when the signs are different. We subtract. Now, do we change that exponent? No, it just stays x to the second power because that's the hundreds place. 5x plus 4x is 9x because we're adding the coefficients. And then 3 plus a negative 7. Again, we change that to a negative. We're really talking about negative 4. And again, these are all different. It's in descending order, making it a trinomial. Okay? Next up, what if it's written horizontally and it's not written vertically? This time we think about maybe distributing to each one of these terms. And so a negative to a negative is positive 2x squared. A negative to a positive is negative x. And a negative to a negative is a positive 3. Now that first trinomial is unaffected. It's simply 4x squared minus 2x plus 7 still. And now that we have changed this to like an addition problem, I can go back and try to identify like terms, only adding the number in front, okay? 4 plus 2, 6x squared. Negative 2, maybe drop the 1 down to remember that's a negative 1. Same signs here, both negative. We add them up for negative 3. Finally, 7 there, 3 there. This is really 10. Okay? So again, 1, 2, 3 different pieces. Trinomials are pretty famous. There's your trinomial. If there is a number, all right, or a term out in front here, then we're going to have to distribute because this is multiplying. And so we're going to multiply before we think to do any adding or subtracting. So this, again, was a negative x squared. So a negative times a negative makes positive 3x to the second power. A negative times a positive 4x is negative 12x. And then a negative times a negative makes a positive 3. And so once I have distributed, I can bring down the front piece. And I have everything I need. I only need to find like terms. So 6x squared with 3x squared, 9x to the second power, adding the number in front. Squiggly, squiggly, those are like negative 10x. Be careful of your integer rules. And then, I don't know, let's just do dots. Dots. Now that's a negative 3 with a positive 3. Ends up at 0. Do we need to write the 0? No, we do not. So I can get rid of it. And then our first one ends in a binomial because there are only 2 terms to this polynomial. We've got a little negative sign there. We got parentheses. And in order to get rid of those parentheses, we are going to have to distribute. We are going to think to multiply before we add. So this is going to be negative x squared minus, because it's going to change everything to its opposite, 4x.